Hi, everybody, and welcome back to Dev Show. My name is Sherry List, and I'm your host today, together with my good colleague, Rasmus Jack. And today we have the 14th episode of Dev Show, which is amazing. And this show is all dedicated to Blazor, which Rasmus is going to talk about it in a moment, about the topic and our speaker. So before that, I want to mention you two things. One is that please use our chat functionality, no matter if you're on Twitch or on YouTube. Let us know where you're watching us from. And also ask your question during the session in the chat. We're going to highlight it and our speaker is going to answer it after the talk. Speaking of typing the question, please be mindful of what you're writing, and I really recommend you to familiarize yourself with our code of conduct, which is, yes, thank you, Rasmus, which is on our main meetup page. The second thing I want to talk about is that all of you are going to get some prizes today. Everybody is going to get a Heroes Learner badge. I'm going to highlight the link here and also in the chat. And so you all are going to get that. But in addition to that, for those of you that you're going to give us feedback by using our feedback form, you also will get some additional prizes as well. Rasmus is going to talk about the feedback after the show as well. So I'm not going to take more of your time. Handing it over to you, Rasmus.
Yeah, thanks, Jerry. So, yeah, as you said, it's the 14th episode today, and today we are actually gonna have a guest back on the show. So today's speaker was also on the first episode of Dev Show. So that's kind of amazing. And as you said, today is gonna be all about Blazor, and the title of the session today is gonna be Blazor, C# everywhere, even in the front end. So and in this talk, we're gonna learn about what Blazor is, how to build a Blazor app using components, also how to integrate with JavaScript, and how to work with routing in terms of Blazor. So that's going to be really exciting. Look forward to that. Today's speaker, as I said, he's back on the Dev Show, and there you are, Chris. Welcome to the Dev Show. I'm just going to talk about a little bit here. You are, as we also learned the last time, you are an Azure Hero Senior Cloud Advocate at Microsoft. You've been in the IT industry for more than 15 years. You have been developer, architect, working in various tech stacks like .NET, JavaScript, Python. And then you've also been speaking at more than 70 conferences, and also a published author and also a blogger. So welcome to the Dev Show again. Welcome back, Chris. It's a pleasure to have you here. When we talk about those blogs, is there any places where we can go read your blogs?
Yeah, thank you, Rasmus. Thank you, Sherry, for hosting me again. I'm very excited to be here for the second time on your 14th episode, so congrats on that. The easiest way to see something that I've been writing is dev.to/softchris. That's, I would say, my primary place. I also have a softchris.github.io where I write a lot. It's pretty much the same article. One of them is my own self-hosting, but dev.to is a great place to be for any kind of tech topic.
Okay, we're gonna share the links in the follow-up email so everybody can go and look what you're writing there.
Yeah, so, and also you're also writing many of learning paths on the Microsoft Learn platform as well, true?
Yeah, for sure, Sherry. aka.ms/learn. This is where we have a lot of Learn modules. I believe we have 1,000 of them, give or take a few. Yeah, definitely. I've been posting on Node.js. If you didn't know, we have a 5-part path on there. And now recently, we also published a 4-part path on ARM. So if you're interested in infrastructure as code, there's definitely something there for you. So we're always cooking up something. So.
Great.
That's amazing. So I think yeah. Again, welcome to the show, and I think Sherry and myself we're just gonna pull a bit back, and you can dive into today's topic. We look forward to learn more about Blazor. Take it
Thank
away,
you for that.
Chris.
Thank you so much. All right, can you see my screen? All good? All right. So Blazor everywhere, or rather C# everywhere. My name is Chris Noring. As Rasmus was already saying, the easiest way to come into contact with me is probably Twitter, Chris_Noring. Happy to get any kind of feedback, or my IMs are also open. So if you got any questions, definitely send me a message. All right, Blazor. One thing we need to understand about this framework is that it can be hosted in two different ways. And what does that mean? Well, there is Blazor with WebAssembly, but there's also Blazor as part of an ASP.NET Core application. So it can live in two different places. Now, when it runs as part of a browser, that means it's restricted in the same way as a normal web application would be restricted by a browser. That means whoever goes to your web page, they don't have to worry about security because the application is sandboxed. It can't, for example, access your file system in there. But one of the great things about Blazor, because it is .NET, because it is C#, that means that you can use standard libraries in there. That means that everything that you come to love about .NET, you can use that in Blazor. And that also means that, for example, domain logic that you've written for the backend, you can suddenly use that for the frontend as well. Let's try to contrast and compare the two different hosting alternatives. So let's start with the one called client-side model or client-side hosting. There are some definite pros, some definite advantages to do so. There's no server-side dependency. This is once it's compiled, it is an application that you can easily deploy onto Azure or GitHub or any kind of static hosting. It also takes away a lot of the power or effort that you would normally put code-wise on a server, because you're moving a lot of application logic to the front end, and that could be good, right? So your backend doesn't have to be responsible for everything. Now, on the con side of things, because this version runs in a browser, that means it's restricted by what the browser is able to do. And it's also good to understand that not every single browser out there will be able to run Blazor in this format, because it needs the browser to support WebAssembly. Now, most current up-to-date browsers do so. They do support WebAssembly, but there might be some older versions of browsers that doesn't have it, and that takes away this option for you, sadly. One thing to note is that once you compile a Blazor application and that's meant to run for the browser, it needs to take part of those .NET libraries that you're actually using in the app. Those need to follow you out on the front end, which means that the bundle size of the app is a bit bigger than the server-side option. There's also some limitations on the on the .NET and the runtime, and the tooling support is less mature. I will, however, talk about that in a separate slide, because in my opinion, it's almost as good now on the front end and the client side as it is on the server version. Now, looking at the other option, the other hosting way, the server side, on the pro side of things, the size is much, much smaller, because the Blazor application is not a standalone thing anymore. Because it's part of an ASP.NET Core app, that means that most of the things that's in there is already part of the application. So your Blazor is just a small subset, which means that the Blazor app itself is vastly smaller. As for tooling and debugging, this works really great, and it's super easy to set a breakpoint and go through all of your layers as your application runs, all the way from database to backend to frontend. And yeah, it's not restricted anymore by a sandbox in this case, so you can definitely use the full .NET and all the compatible APIs. One downside is latency. It works a bit differently when it's being hosted on the server side of things. What you have is a separation of a backend and a front end part, and for those two to communicate, it becomes a network call. So that means that latency is a thing. It also means that you don't have any concept of offline when you host it this way. So if you don't have an internet, you don't have a nice thing such as progressive web apps, so it works offline, but you don't have an app. So if you have no internet, you don't have an app with this version. And scalability becomes an issue because, as I said, because of the way the server-side hosts this in a separate backend and front-end part, every single app instance is a connection between these two parts, which means you run into a scalability issue when a lot of people are using the app. Now, how do I get started? I mean, this is one of the first things. I'm excited, right? I'm a .NET developer, I'm a C# developer, I just want to start. Well, we've grown used to the fact that we have a command line tool, .NET, and thanks to that command line tool, we can easily scaffold a project. And when you are, I believe, installing .NET Core 3 and above, you are getting this project template for free. You don't have to install it extra. So you have this Blazor WebAssembly, that's Blazor WASM. And yeah, the -o flag simply means this is the name I want to give of my folder as I scaffold my project into it. So scaffold the project, build the project, and then run the project. It's that simple, right? And this is what you're getting out of the box. So you get some kind of notion of a menu to the left and the application surface on the right. And yeah, let's talk about development tools there for a second, because I said that potentially the server-side hosted version was a bit better in terms of tooling. But let's dive into specific IDEs and specific text editors. You have Visual Studio for Windows, right? If you're a Windows developer, you're used to having an amazing IDE, because it is. I've been using Visual Studio for Windows for a very long time, and Blazor is fully supported. You got a project template, you got syntax highlighting, and you got a debugger, and everything is nice and sweet. Then you also have a very good text editor / IDE called Visual Studio Code. This is an amazing tool to use for whatever kind of language nowadays, thanks to its plugin and extension system. So regardless of whether you're coding in Python, JavaScript, or C#, you have a decent or even really, really good experience. How does that look for Blazor? Well, for Visual Studio Code, you definitely can scaffold the project template. That works through the command line, and you can also set debuggers. What you don't have, though, is syntax highlighting in the templates. But if you're a Mac user, there is some amazing news, because with Visual Studio for Mac, it now supports Blazor fully in the same way as it does for Visual Studio for Windows. So if you're on a Mac, I definitely recommend that you download Visual Studio for Mac, because you have a project template, you have syntax highlighting, and you even have a debugger that works really, really well. All of my demos that I'm about to show you has actually been recorded and been using Visual Studio for Mac. So if you haven't tried that for various reasons and you're on a Mac, definitely have a go. So, components. Most frameworks today, when it comes to web development, are component-based, and that means that a big application is usually not one component anymore, but many different focused parts. And the reason for wanting to have components is because maintainability. We don't want all developers in a project to work on the same file, but we want to make sure we slice it up a bit so we have different focused components. Now, that's maintainability, but it also enables reusability, because the smaller components you have, the more likely you are to use those elsewhere in the application or for other projects. So always think about, what components do I need? Now, you don't want to prematurely optimize this and have a million components, but definitely think about having components. There are two ways in Blazor in which you can author components. I'm going to talk now about the first way, the way that existed first. And that's the one that's using a Razor template and one file. So that's the first version of it. So what you're doing is you give the component a name, and then you call it .razor. Now, if you're inside of Visual Studio for Windows or for Mac, you will have this nice syntax highlighting and auto-completion, and you can easily see what's what. Looking at the top here, we are starting with a page directive and on line 1, and it says /counter. This means it's a routable component, so if you were to change the URL in your browser, it would know where to go and what component to render because of the URL that you're currently on. Now, if you're a .NET developer and have been so for a long time, Razor is old news to you. You know exactly how Razor works. It's easy for you to intermix between HTML and your C# code. But just to humor the rest of you who might be new when it comes to C#, here on line 5, you see how I'm using the @ sign to output a variable, the current count. You also see I'm doing the same thing on line 6, but for a different variable. On line 8, I am hooking up a method to an event. So here I'm having this onClick event, and I'm hooking it up with increment count method. And looking from line 10 to line 19, we see that we have a code section. So this code section contains different private parts of your component, such as current count, a variable, number, also a variable, and lastly, a method called increment count. And you can see that were I to click the button, it would invoke the increment count, and it would increment a current count and number, and we would see that reflected on line 5 and line 6 respectively. So that's really the anatomy of a component, the feeling of having markup intermixed with C# while using Razor. So markup, code part, that's the part you need to keep apart. Having said, this is not the only way to create a component. They are actively working, if they're not already finished, with a version in which you would have a code behind. So you would have a separate markup file and a separate C# file. It either already works or it's very close to working. So that's for you who like, separation in a different way. And definitely if you're on VS Code, for example, you would, you could utilize the C# syntax highlighting, for example, if it weren't intermixed with HTML. So that's really good news for you on VS Code and for you who'd like this separation. Let's talk about input. When it comes to components, you usually say two different things. You say that data flows from the top and downward. So you have this top to bottom approach, but then you have this notion of events. For example, someone typed something in a text input or a button was clicked. That's event being raised and they flow upwards. Component input is about the ability to take data that is on the top level and send that down into various components. And the way we do that is by exposing different parameters. Looking here at the top image, we can see how we have this square bracket parameter around the property where we say string title, and we are exposing this to the outside world. So if you remember the previous image on the previous slide, we didn't expose anything. Everything was private variables. They were contained within the component. But as soon as I add this square parameter to title, it becomes public and I can set it from the outside. This is how data flows into a component, and I have the ability to now render this data within the component in the rendering section here from line 1 to 3. Here's another parameter. It's declared the exact same way with a square parameter, this time for a variable called description. Looking at the bottom image though, we see how we are in a parent component. We are utilizing this component that we call product detail, and we have two different properties, title and description, and we can set those from the outside, and we know that that data is going to flow into the component, and the component itself is going to render this data for you. So that's how the component input works. Just remember this square parameter bit. What about output? Let's just recap what output is again. Think of it as having a parent component and a child component. This is the case, for example, when you have some kind of list, some kind of to-do list, and you might have the edit capability on this list. So you have a list of components. For a specific item, you choose to, hey, I want to go into that component and I want to change this item to something else. At that point, you might hit the save button. What you want to do here is to ensure that one, the child component doesn't know so much about logic. you want it to be a simple presentational component, but you want to tell the parent, like, hey, I've actually changed. Can you take care of it? So this is our component output. This is our ability to communicate from a child component to a parent component, in which we're saying something happened and you need to care. Looking at the left here, we see how we have our child component. It has 3 parameters. Instead of the old component we were looking at, now we actually have a third parameter here from line 14. And this parameter is of type event callback. Now this is important. When we make it of type event callback, that means it's an event that we can register to it. And how things normally work with events and .NET is that we have an event and we connect it to a method that gets invoked because of it. On line 4, we can see how if we were to push a button, we would actually invoke the onClick by calling the invokeAsync method with a payload. And the payload in this case is a title. Now, returning back to line 15 again, we can see that we have a type. We have event callback, and then we are templating it to be of type string. What does that mean? Well, the string here means the input type. So what we're saying is, whatever we call invokeAsync with, it needs to adhere to this type. So title here on line 4 is a type string. So if we were to send it an integer, for example, we would get a compilation error. Now, going back to the parent component, we have a list. We're using a for each to show X number of product details. This is a typical to-do list or master detail kind of scenario. What we're doing is to hooking up the onClick event callback to clicked, and clicked is a method that we can see. So every time someone clicks a button on the child component, it will call this event callback that will call invokeAsync that ends up calling this clicked method on the parent. So that's how this whole chain works, from event flowing upwards from child component to parent component. Hope you're with me so far. I'm going to show you a little example of how you could be creating your own component. So I'll have a pre-recorded demo here for you to see. Let's see. Okay. We are inside of Visual Studio for Mac. So if you've never seen that before and you're a Mac user, I wanted to introduce you to it. It looks a lot like Visual Studio on Windows. The first thing we're going to do is here on the right, we see we have a pages directory. Now you don't have to place all your components in there, but if they're routable, if this is something you can navigate to, they should be in here. The important part for a component is to end with this .razor file ending. So what we're doing here is to right click on pages and select and give the component a name. So we call it something test.razor. I need to learn how to spell razor. Once we have that, we can just remove the code, and we start with something as simple as a page directive. Now, this component is not something we're going to route to, so we could actually skip line 1 if we wanted to. The important part is that we have the @ code here from line 3. Next thing we do is to create markup. So we have a div, and we want to display something within that div, so we need a backend field. So we create that field with string title, and then we give it the parameter. But a parameter needs to be decorating not a simple string title, but rather a property in C#. So we need to change from string title to that of a property. So we're going to mark that up, and we can hit prop. Prop is one of those short things that if we tab it a couple of times, we get help typing out our property. So it's string property, we call that title, and now it's happy. We have decorated our property title with a parameter, and now we can output our title, and we get all the autocompletion that we expect from a good IDE. And yeah, so that's us finishing authoring this component. We're just going to save that. The next thing we're going to do is to use that within index.razor. This is our starter component. We're going to take away a few things, and now we're going to put this to good use. So we're going to hit test, and right. And we're also gonna assign the attribute. So we have a title attribute and we can assign it some text, and we know that this will be rendered by the child component. So at this point, we're happy, and we just start off our application, and this should automatically start a browser for us. Takes a few seconds, it needs to compile and then it needs to run. But once we've done that, we're going to have a window that's hosting our app. We have our app, and we have my title showing as our component test now is being rendered. Awesome, right? Let's see. All right, so next up, let's talk about HTTP. Because HTTP is something you are very likely to use within your applications. We have a dependency injection system. So this makes it super easy to just use things such as HTTP. All we need to do is to hit HTTP client, give it a name. In this case, we call it HTTP. We could call it something else. I like HTTP. And once we have that, injected that, we are ready to use it. So now you'll learn a bit about lifecycle methods in Blazor. We're not going to spend a ton of time on that. Documentation is really great on this point, but it's good to know that on initialized async, this is the method in which things should happen that should be part of the rendering process for your component. So what we're doing here is to go to the Star Wars API, swappy.dev. If you haven't used that and you're a Star Wars nerd, just like me, definitely go to Swappy and check out everything on heroes and planets and vehicles and God knows what else. What we're doing here is we take our HTTP and we call get from JSON async. So we go towards a certain URL. And in that process, we convert the response, which is a JSON, into a planet request. And the planet request is just below, and it gets back this results. And we again type it to be of type planet. And yeah, that's pretty much how easy it is to use HTTP. Just remember to inject the client, and if you want a more complicated version in which you post or you get, there are other methods on the HTTP instance that you could be using instead. But if you just want a simple JSON, this is the way forward. And yeah, once you get the results back, once it has resolved, your for loop will just iterate through the results, and you get a every single planet in the Star Wars ecosystem to show. So that's pretty neat. Okay, so we've learned so far how we can build a component. We have learned about input parameters. We have learned how to use HTTP. We already know a lot and we can almost feel productive, but any good application out there has the concept of routing. And routing simply means that we have many different pages to our app that we can go to. So we might have a orders route, we might have a user details route, and so on. There are different areas of our application that I want to go to by changing the URL at the top in the browser. We've hinted to how that works before, but now we will talk about it a little more in detail. It starts with the page directory here at the top, and it starts with a slash. So you can't forget the slash, but anything that comes after that is what it will match. So it will try to match in the browser what you've typed there as part of the URL, the last part. And if you've typed /counter in the URL in the browser, it will match by rendering this component. I think I forgot to say, yeah. So page directive is one thing, but we also have the concept of route parameters. So not only might it be /counter, but it might be /counter /something. And that something might be a number or alphabetical or some kind of GUID maybe, some kind of unique identifier. Lastly, we also have a concept called query parameters, and those are everything that happens after the question mark in a route. So here, for example, we have query parameters page and page size. This is a way for us to express to the backend that, hey, we don't want all of your 2 million records, but rather 20 of them. We want from the first page, and we assume that this page size is 20. This is a great way to offload the backend and just instruct it and say, hey, we don't want to wait for the full 20 minutes for all of these records to come back to us, but we want something that the user can actually get within a second or two and they can act with. Route parameters. As I said, we have route and then a param, but you can also give this param a type. And this could be pretty good because it means that you can send anything in from the URL, and it will try to coerce whatever happens in this route parameter to be of a certain type, so it's easy to use. Looking at it from this aspect, we see that in this case, in the top directive here, we have /product/ID, and ID is of type integer. So we coerce it and try to convert it to be of type integer. And the next thing okay, I've messed up the slide here, but what I can tell you, if you look from the code section here, you see that we have a parameter and you see that we have public int ID. And this is for us to dig out from the route and say, hey, can you please bind whatever this value is in the route to this parameter? So int ID will now contain 1 or 1000 or whatever else we put in the route. So that's kind of good. Okay, I need to fix these slides before I send them across to you, Rasmus and Sherry. But moving on, what's more important to know about this is that if you look at it, we see that there's another lifecycle method that we care about. It's called onParameterSet. OnParameterSet has the mission to wait until a certain parameter has been bound. So in this case, it means it's part of the lifecycle process in which we can ensure that int ID has a value. So before that, it doesn't have a value and it's not meaningful to go towards the backend and fetch a specific record. But on parameter set, we can expect the route parameter to have been assigned. And at this point, it makes sense for us to call get product, and we do so with the ID parameter. And back comes, of course, one product record. Right. So let's talk about navigation, because so far we said, okay, I hear you. We have product/1, and we're able to dig out the one, and we're able to look up a certain record. But I also want to navigate in different ways. We are used to two different kinds of navigations. One is, of course, to click a normal link, an anchor tag, and say, hey, I want to go from this page to somewhere else. But sometimes we want to do so programmatically in code. We want to express that, hey, I'm done saving this record, and at this point, I'm done to go back to a list page, for example. So looking at it from that aspect, we have the nav link. This is simply a wrapper around the anchor HTML tag, and it allows us to navigate and within our Blazor app. This is one way. The other way is to first at the top here inject something called the navigation manager. The navigation manager is able to know a lot of things such as your route, your query parameters with a little help and a little digging, but it's also capable of navigating you here at the bottom to the route of your choice. So all we need to do is to call navigate to with products to end up on /products. So that's two different ways, one being the nav link and the other one being the more programmatic approach of injecting the navigation manager and calling navigate to. I talked about query parameters. I mentioned those initially and said, hey, if you got a big set of records, thousands or 10,000s or even millions of records, you shouldn't ask a query to the backend where you say, I want all the records. Because if you get all the records, you're going to be here all day. So what you need to do is to use query parameters as part of your URL. In this case, we have a route. We are specifying a page and a page size. Now, the interesting question becomes, how do I parse that out? Because that's not ready and able for you to use. You need to do a tiny bit of parsing first. So what you do is you add a package, a NuGet package. You have this package, I believe, in ASP.NET Core already, but for Blazor, we need to add it. It's the one called Web Utilities. Once you've added that, you have the capability of parsing out. So the first thing we do on the line above here, we see that we, 1, inject the navigation manager. 2, we're asking it for its URI. Once we have the URI, it disappeared a little bit. It's calling URI.query. And .query simply means that we have something that's separated by and sign. So we have page equals 1 and page size equal 20. We want to parse that out so it's easy for us to manage. So we call parse query and we end up setting this param and assigning it to page param. We do so again this time around for the one called page size. So we do that once for every type of parameter that we want. Once we're done with that, we have the ability to call our backend and say, hey, please try to slice down whatever response you give me, and please obey what page I'm on and what page size. So in this case, I would only get 20 records back instead of 10,000. Let's see how that works in code, because sometimes it sticks better if you see an ID, am I right? So let's talk about that and show that most of all. So here we're inside of Visual Studio for Mac again. Nice syntax highlighting. We have a list of products. It's using navlink. What we want to see is how we use this web utilities query helpers method. So we will try to parse out the query portion of our URI. So first we get the URI itself, and then URI.query, and then we call this try get value, and we give it this page argument, because that's the name of the parameter that we want to dig out from the query part. And lastly, we want to assign that on line 26 to the page param. We need to do the same thing again to parse out the page size and assign that to a variable. We're using this out construct to make sure that it's being set in there. And lastly, we call get products with these two parameters and hope that our answer that comes back is nice and sliced. Looking at this get products, we see that we give it default values if we weren't giving it any, but we use the skip and take from the link library, and we're able to slice down the size of the response. Now we have this kittens component, because everyone loves kittens, am I right? We want to run this, but I'm just highlighting /kittens because that's the URL for our component, so we can reach it. So we go in here, we type kittens, and we end up on a page that shows all the records. Now this isn't terrible, right? It's just 4 records. But imagine us now typing page 2, and we slice this answer a bit. We say page size of 2, which means we get 2 records instead of 4. That works great. 2 records. We can change back to page 1 instead, and we'll see the 2 first record on the first page. So that's how you could be utilizing the query parameter as part of Blazor. That's a lot already, right? I bet some of you are yawning a bit, almost falling asleep, but don't worry, I got you. Forms. Forms are one of those things that you might not go whoopee over, right? Most of us likes other parts maybe, but forms is the way that we collect data from the user, and being able to collect and validate that that data is correct before we persist it somewhere, that's crucial, right? And we can spend so much time in here configuring all the various ways that we can validate. There are definitely some setup components already for you, so part of the heavy lifting is done. Now on HTML, we use the concept of a form tag. They have wrapped that into something called edit form. But there are different ways to handle the form, of course. There is the built-in notion in which we just say, I have a form, I have X number of input, and I want to be able to annotate those parameters and say that you're of type string, you're an integer, you're a Boolean, and you should match some regex pattern. But there's also situations where we want to trigger the validation from code. So for whatever reason, we want to ensure that maybe we started editing in our form and we want to go towards a server side and say, hey, can I please validate and make sure that whatever, before I'm sending it server side, and for example, see if a company name is occupied in the company register, can we please try to validate the form? And this kind of allows for that. But looking at, first off, let's look at the simple form version. So this is as simple as it gets when it comes to Blazor and forms. From the top, we will start in the data annotations model. So we have the concept of a model, and a model is simply something that has properties. So we call it input model, but you can call it whatever you want. We leverage the fact that we have a data annotations library that will help us express things such as that something is required, or maybe it needs to have a certain string length, or maybe it needs to match a pattern. Now, I know an age normally is a number, right? But, you know, humor me here. I'm just trying to show you how you can add different annotations. And here we also have a different one called name, and we're simply saying that name is too long if it's more than 10 characters. That's a bit mean, but that's our system. You can improve it. Right. So if we go here to the top, the markup portion of our component, we see that we have the edit form. We also see a model, and we are binding it to a model instance. If we look at the code section and the very first row, we see that the model is of type input model, the class that we have below here, and we do some initial setting of the values. We also have the onValid submit event callback, and the onValid submit event callback on the edit form is simply saying, I will only be invoked if this form actually checks out. If this form is valid, then I will be triggered. On the next line there, we have something called a data annotations validator. This is simply a validator that's already written for you that has the capability of walking through your model class and look for different annotations and ensure those annotations are correct. So it compares the rules that you set on it versus what value it currently has in the form. Now, validation summary is a component that outputs all the errors that you might possibly have. Then you have an input text, and the input text binds its value by the bind value attribute, and it's saying model.name. So it's gonna look at model.name from our model and say, hey, I'm gonna keep a track of you. And then we have a submit button. So yeah, this is the hello world version of a form in Blazor, and it does actually quite a lot of heavy lifting for you already, but there are different versions. As I said, you might have situations where you want to trigger your form from code instead. So if we look at this, we see that we have, instead of a model, we have bound it to a context. Now, a context is an object in Blazor that keeps track of the form and what state it's in. And the reason for using that instead of a model is that we need to invoke methods, and we need to check certain states on the form that we wouldn't be able to do just by looking at the model. So we use the context instead of using the model. So you can't have both at this point. If you were to assign both the model property and the edit context, you will get an error. So choose one. But now we have more power because we have a context object. And we are, instead of using on a valid submit, we say on submit, which essentially means as soon as I push the button. So it's not doing any validation at this point. Looking here at our submit method, we see that it instead actually programmatically does the validation for us. So it calls the context instance, and it calls validate. The end result is a Boolean, which is either true or false. If it's true, then we have the ability to do whatever we need to here. We could be setting an error message, or in this case, clearing it if it's valid, or we could be doing a REST call, for example, to validate whatever's in the form. You decide. But this gives you the power to programmatically control the validation process. Now, this one is a little bit tricky. What this one does is custom validation. I will definitely show you a better slide than this. This is just so the slide looks pretty. But let's talk about what this is and what it accomplishes. Well, custom validation is when you have business requirements. You got domain logic that's not covered by required, or it needs to be a string. You have something more complex that's very specific to your business. What you need at this point is a custom validator class. And you need to write your own validation logic because only you know the business requirements. Let's have a look at what that looks like. You have a big custom validation class here. It needs to inherit from something called component base, and it needs access to something called a message store. Now, a message store is a simple being. It's a dictionary. What it keeps track of is what field and what error message should be on that field. So that's a fairly simple data structure. What else? We need the notion of clearing an error. And once we clear an error, it's not just about clearing the message store from whatever errors are in there, but we also need to tell the context object, this complicated object, if you remember the last form, we need to tell it that, hey, I cleared my messages and I should notify the overall form that something has happened. So for example, the validation summary can be cleared and the error messages disappear. So this is just a signal that you send upwards. And then we have a method called display errors. Display errors the only thing it does is add messages to the store. And here we're adding a specific field and we're adding a value. And the value is the error message. So this is this method will be invoked. I will soon show you how. But two things. It adds error messages to the store, and it also tells the overall form component that, hey, here's a change and you need to care. That's what we do with notify validation state changed. That's a lot, but the good news here is that this custom validator class kind of looks the same regardless of what you try to do. So if you have a lot of, I usually create one of these per project. I don't need a ton of them because I know that the validation logic doesn't live here. So looking at using this approach, we see that we have an edit form. This time around, the edit form has something new to it. We have added the custom validator as an element. And we add this instance of a custom validator, a so-called ref. Once we do that, we need to realize that we are now in charge of checking validation errors. Now, we do have the data annotations validation, so that is still going to happen. It's still going to tell me that a field is empty, or it's not of type string, or it matches or doesn't match a pattern. But now I can add my own business logic. So the first thing I need to do is to tell the custom validator, clear all the errors. This is about clearing our internal data store. And then I need to say, field by field, what should I check extra? So here I'm checking, for example, that the age starts with a 1. And if I notice that that is not the case, then I'm simply saying, I'm going to raise an error of type model age. And here's a nice little error message so the user understands how to fix this. And one of the last things I do, if I have errors.count larger than 0, that means I have already put X number of errors in here. I end up calling display errors on my custom validator, which, as we knew, notified the edit form. So this is as complicated as it gets when it comes to form validation. But luckily, you have all the slides, and I'll make sure to also distribute a GitHub repo for this, so you can see how you could be writing this yourself. Right, but let's look at this in code. Again, PowerPoints are one thing, seeing it in code is another. So let's have a look at a simple form. So here we have an edit form, and first thing we did is to start the application. So we are just waiting for the browser here to pop up once it built everything. And I just wanted to take you through a scenario in which our very simple form, first off, we navigate to it by changing the edit, and then we try to submit, and it's telling us that both age field is required and name field is required. But I only have the name. What's up with that? That feels like my form isn't done, right? I need to add something to it to make it work. That's exactly it. So I need to go in within my edit form. I need to add a label and an input text that now covers the model.age. So now suddenly I have two inputs. So in theory, I could be inputting values to both of these fields. And just having a quick check, making sure, oh, what was the validation messages again? Okay, so we've updated our markup. That's good. And we're going to start our application again. And this time around, let's see if we can make our form valid. So we build our application, we run it, and we just need to navigate to the form again. So input/edit. Now we have our form. This time around, we have two different fields. It's still mad at us. So we try to input something in name. It's mad about the age, so we input something in there and we say submit. And now you can see that we have green as a value on both fields. So name and age are both green, and that's great. So that's how you can see that forms could be working for you when it comes to Blazor. JavaScript. I started this talk by saying, hey, Blazor is C# everywhere. Why should I ever need to care about JavaScript? Because one of those opinions I hear about Blazor is that, oh, good, I never have to see JavaScript ever again. You know, I look at it as an opportunity because I know a lot of you probably are supporting business applications that for the foreseeable future will be written in JavaScript. You might have a library that's written in JavaScript that doesn't exist yet in .NET. And for that reason, you're like, I don't want to wait for this to become .NET. Or you, as I said, you might be maintaining something existing. And for that reason, it's quite nice if we can utilize what we already have instead of reinventing the wheel. So there's this notion of an Igs runtime. So this is a JavaScript runtime that has the ability to call JavaScript code. And you can get the results back into your C# as well. So first thing we do, as we've learned before, if there's anything we need, we inject it. So we inject the JavaScript runtime. Once we've done that, we can call a function. So in this case, we are calling the invoke async method with the first thing we're specifying is the name of the method and then X number of arguments that it takes. Looking at the right side, we see that we have a script file, and this script file is something that we have referred to within our index HTML. And once we have that script file, we see that it has the add method and the common elements. In this case, the add method, as we see, is very simple. It takes 2 parameters and returns the result. And back here on the left side, we see that the result is being assigned to our result variable, and we can show that as part of our Blazor component. Now, I have a lot more advanced example in which we are, I believe I am downloading Lodash, and we can definitely use those capable libraries within our Blazor applications as well, thanks to this runtime. That's a blog post and probably a lecture all to itself, but I believe I am leaving that as a link at the end of my slide deck. That was a lot, right? Take a breather. I'm going to take some air at this point and just think about everything I've been saying, right? So Blazor, C# everywhere, 2 hosting models. You need to choose whether to run it as part of an ASP.NET project or as a WebAssembly. I have been saying that WebAssembly is definitely a great option, but depending on your landscape and your company, it might make more sense to run it in an ASP.NET project. The WebAssembly is limited. It's running in Sandbox, but so is every web application out there. It's, you know, it's for your own good, right? So regardless of hosting model, you get access to .NET libraries, which is a fantastic opportunity to reuse code everywhere, and you don't have that context change when you're like, oh, how did I type this in C# or JavaScript again? I can't quite remember, and you waste a lot of time of having to Google things that you knew that you knew, but you know what I'm saying, you don't want that context change if you can avoid it. Visual Studio for Mac, that's what I've been showing throughout. If you're on a Mac, definitely download that. Blazor has great support. If you're on Visual Studio Windows, you already have all that great support with syntax highlighting, debugging, and project template. Visual Studio Code is still pretty good and it's free. You have a project template and you have debugging. You don't have syntax highlighting, but as I said, the Blazor team is working on a code behind solution in which it would separate completely the HTML from the C#, and there are extensions to highlight that in a nice way in VS Code. Lastly, how you learn more is my 3-part series where I go first, I talk more in depth about Blazor, how it works with updates, why to choose different hosting models. I got a very long, it's not a very long article, I think it's 7 minutes long. I have a separate article to talk about JavaScript interop if you got more advanced scenarios using libraries from NPM, and a separate article to cover routing. There's also 2 different Learn modules. One Learn module covers how to do everything I said today, the Blazor intro, and there's one Learn module dedicated towards static web app service and how you can easily build your Blazor app and deploy that just by saying, my Blazor app lives in this GitHub repo, and it's going to use GitHub Actions, and you're going to be in business in no time, and you can even opt in to use serverless as a backend if you wanted to. Right. So that's written by Aaron Powell. So if you know him or if you follow him on Twitter, if you got any questions or comments on that Learn module, definitely reach out to him. And that's actually all I had. So I'm going to leave this back to Rasmus and Sherry, who I hope are still awake.
We are definitely awake. Thanks for the great presentation and walkthrough of Blazor. It was really interesting. We have a couple of questions, and to all in the audience, I know that we are on time, but we're just gonna take there's 2 questions, so we can make sure that that people can get them answered. So we have a question from Christian here, and he's asking, do you have any tips in regards of determine what is a fit for a component and how to organize your components?
Excellent question, because as always in everything computing, it depends. But I usually like to think about 2 different things. I like to think about smart components as holding the data initially, and the dumb components in the sense that all they do is to present data. So if you feel that your component is doing too much, if it's doing more than one thing, it should probably be a separate component. I don't want to see 20 different components for a very small app, but if I were to give you a number, I would say it makes sense if you have 4 or 5 components on a relatively small master detail. For example, if you got a product list, that's probably one component. A product detail is probably another component. Maybe the input itself is a component, and so on. So I would say it really depends on. For me, the big decider is, will I use this somewhere else in a project, or is there a separate project altogether that could benefit from this? At this point, I'm thinking this could be separate. But I would definitely start with a relatively non-component solution and gradually say, this should probably be in a separate component. So I would start off by 1 or 2 components and, step by step, just lifting them out as I see, hey, these are separate. They can be used elsewhere.
Okay. Thanks for that answer, Chris. The second question here is from Rasmus, and he's, what is the Microsoft commitment to Blazor? Is this the next Silverlight that's going to be killed in a couple of years?
I think that's a fair question. We have to take that. We have people who've been using Silverlight and got a little bit burned by it. But so where this is different from Silverlight is that Silverlight was built on a plugin architecture, right? The notion of downloading and installing Silverlight in a browser, there's no such notion here. And the reason I think this is better positioned than Silverlight is that there's no plugin and it's built on WebAssembly, and WebAssembly is the future. I mean, you have a lot of game companies right now that heavily invest in WebAssembly because they need things in the browser to go fast. And the fact that you have buy-in from different industries that does programming means that WebAssembly as a platform is, the next thing and where you need to be. With that said, I definitely recognize that a lot of people in the .NET circuit are working towards old browsers and might only look at this as like, I want this, but I cannot have it. And I understand that pain is real. But so I would say this, Blazor is a lot better positioned. I am not an oracle. I can't look into the future. But they have been working at this and improving it for several years right now. And I see a lot more buy-in. And one of the signals I look at when it comes to choosing a framework is to see how active is the ecosystem. And last, when I talked to the team members at the Ignite in Florida, they were saying like the ecosystem for Blazor already is huge, because what they're doing is that they're wrapping browser functionality so everything can be used within Blazor. And if you look at that ecosystem scene, that's a good sign of life. If no one is building third-party components or libraries for your framework, it's dead in the water. But I would say that's not the case with Blazor. It's this curve right now, for all I can tell.
Okay, super good. We also just, before we move on, we have one comment here. So from Fabio, it's bring back memory on how to use JavaScript in the web forms years ago. So thanks for that comment, Fabio, as well.
Yeah.
I think that's a fair comment. I remember those days. I think this one is a bit easier to use, but I would say this, it's very seldom that you need it. I mean, it's there for a reason because you need interop if you got a heavy investment in JavaScript. If you don't have that, I don't see a ton of JavaScript being used. Most Blazor apps are very JavaScript. Well, it's wrapped in a component rather than actively used. So fair comment. I smiled at that because I remember those days.
Yeah, thanks for that, Chris. So yeah, thanks for all the questions in the audience, and thanks for answering them, Chris. Let's dive into, yeah, as always, we want your feedback. So and I heard that Sherry in the beginning was promising some swag for the feedback interest, and if you want to enter into getting some swag, please put your contact email in the contact form as well. So go to the feedback form, tell us about how we're doing, tell us about what you like in the future. Also, if you want to be a speaker, let us know. And also, as this topic actually came up from one from the audience putting in that they want to hear about Blazor in the feedback form. So we listen to you. We wanna bring this show to you.
Exactly. And as for the next one, if yes, my computer works, great. So I already put the link in the chat to get your Azure Heroes Learner badge. So we are also going to send it to you in the follow-up emails. So for those of you that you don't know about the program, so it's like a community program from Microsoft that tells you thank you for learning and using our technology, or if you go a step farther to kind of that to even empower people around you. So please go to the website and learn about the other badges that we have, and then how you can nominate maybe some of your community friends, not only yourself, to say thank you to them as well. Yes, of course, my clicker doesn't work. So, and then also we have this page like Azure Heroes Community, where you can go and add yourself to the map and also find the other Azure Heroes around you as well. And so, what are the upcoming events, Osmus?
Yeah, so quickly here. Next week, we're gonna have in the Dev Show. We're gonna have Mark Druger talking about how to deal with persistence in serverless applications. And on the same date, actually right before, Cloud Secrets is gonna talk about green energy and IoT with Thomas. So you can have two in a row there. The week after, 17th, my frontends, Bacchus is going to be back talking about what are they doing at Maersk again. And also the week after, we're going to have Jan talking about Apache Spark. And you can see the full program actually up until January on our meetup page.
Yes. And, Azure Heroes is back. So we have the Virtual Azure Community Day coming up in December. And currently our actually call for paper is open. So I really want you to go ahead and then submit the talk if you're kind of that, if you're a speaker, because we are looking especially for the talks about the real world, about how you're using actually all of our technology in the production. We have a track called Cloud Secrets. That in that track we are going to highlight talks about the real world scenario, and also some secret function that you might use it in your project that not everybody else knows that. So yeah, scan this QR code and then go to the submit the call, submit the talk there. And if you're interested in the .NET, we have at Microsoft on the November 10 until 12, we have the .NET Conf. That if you're watching us from Learn TV, is going to be on Learn TV as well. And then we have another thing called Cloud Skills Challenge, which is based on the Microsoft Learn platform that we have. And currently we have one challenge going on is focus on .NET, you can use the link below and then actually go with your friends, because you can you can use it as like a team against team, and then go through the challenge together, and then show up at the leaderboard that we have there. And the best way to contact us is on Twitter. Both of our DM message is open, and I would say thank you for all of you watching us, for Chris, for coming back to our show, and hopefully see you all next week on 10th of November.
See you. Bye
See you.
bye.